Why the strength is so less? Okay, shall we start? Write in the message box. Shall we start? Yes or no? Okay. Whether my voice is clear? Whether PPTs are visible to everyone? Okay, no issue. Now we'll start. So in the last lecture, we have seen the designation system of halocarbon refrigerant. So whatever halocarbon refrigerants are there, those are designated by the formula that is nothing but R dash XYZ. Whereas each and every word is having specific meaning. So in the last lecture or in the yesterday's lecture, we have seen how to write down the refrigerant number based on the refrigerant or a chemical formula, and how to read the chemical name based on the chemical formula. And in the reverse way also, we have seen if you are knowing the refrigerant number, then based on the refrigerant number, how to find out the chemical formula as well as how to find out the chemical name, that we have seen. So just like a overlook, we'll see this. So we are knowing that whatever halocarbon refrigerants are there, those are designated by the term R, X, Y, Z. Whereas those are designated by the term called as a R, X, Y, Z. So each and every word is having the specific meaning. So here Z is indicating the number of fluorine atom. Y, second digit, that is nothing but Y, is indicating the number of hydrogen plus one atom. Then third digit X is indicating the number of carbon minus one atom. And here whatever R term is there, that R is indicating the refrigerant. For halocarbon refrigerant, instead of R, we can write as a, what we can say, or what we can write instead of R, we can write as a F also. Why F? Because all the halocarbon refrigerants are coming under the fluorine group of refrigerant. Sorry, freon group of refrigerant. So you can represent that freon by F also. So here, if any vacancies will be remain, then the balance indicate the number of fluorine atom. So as we are knowing that carbon, if one carbon will be there, so that one carbon will have the 4 valency. If 2 carbon will be there, so there will be one carbon-carbon bond between these 2 carbon. So each carbon will have the 3 valency. So if only 2 digit will be there, that means suppose R11, R12, R13, then in that X is indicating. So R11, R12, R13. If you are going to take the example as a R11, then here value of, in case of R11, value of X will be equal to 0. So R11 is nothing but R011. R011. That means value of X will be equal to 0. And value of Y and value of Z will be equal to 1, 1. That means if only 2 digit will be there, then in that case, X will indicate the 0 value. So if you are going to consider the example of R22, so here from that R22, here first digit, that is 2, is indicating. First digit, that is nothing but 2. That 2 is indicating the number of fluorine atom. So number of fluorine atom will be equal to 2. Second digit is will be indicating the number of hydrogen plus 1. That means value of H plus 1 will be equal to 2. That means value of H. That means Y is indicating H plus 1 will be equal to 2. So number of hydrogen atom will be equal to 1. And third digit will be 0 here. as only 2 digits are there. So third, that is nothing but third digit will be equal to 0. So value of X will be equal to 0, which is nothing but equal to C minus 1, carbon minus 1. And based on that, you will get the value of carbon is equal to 1. So as only one carbon is present, so one carbon will have the valency as a 4. Out of that 4 valency, 2 will be fulfilled with the help of fluorine. So number of fluorine atom will be equal to F. 2. Number of hydrogen, here number of hydrogen atom is nothing but 1. So H will be equal to 1. So whatever balance will be there, whatever balance will be there, that will be fulfilled with the help of fluorine atom. That will be fulfilled with the help of fluorine atom. So this is nothing but fluorine. So here R22 will have the chemical formula as a CHClF2. CHClF2. What will be the chemical name? What will be the chemical name? So one chlorine atom is there, that's why monochloro. 2 chlorine atoms are there, that's why dichloro. And 1 carbon atom is there, that's why methane. Monochloro, dichloro, methane, that is nothing but R22. So just as a revision purpose, I have told you this designation system. So in the same way, so chemical formula for R22 will be CHClF2. In the same way, you can find out the chemical formula for R12 as well as R134A, whereas A is indicating, yesterday only I have told you, what is the meaning of A? Will tell me, what is the meaning of A? Can anyone tell me, what is the meaning of A? काय म्हणतो आपण A ला? किंवा A काय indicate करते?
Isotope.
That A is indicating the isotope of tetrafluoroethane. Here, if you see the formula C2H2F4, here no chlorine atom is there, that's why 0 chlorine. Number of chlorine atom 4, so tetrafluoro. Number of carbon atoms are 2, that's why ethane. So tetrafluoroethane, that will be the chemical name for R134A, and A is indicating the isotope of tetrafluoroethane. So this was related to the halocarbon refrigerant. Now second type of refrigerant. In the start of lecture itself, or in the start of chapter itself, we have seen that refrigerant is basically divided into two parts. First one is called as a primary refrigerant. Second one is called as a secondary refrigerant. So that primary refrigerant is again divided into four parts. First one is called as a halocarbon refrigerant. Second one is called as the azeotropy refrigerant. Third one is called as the inorganic refrigerant, and fourth one is called as a hydrocarbon refrigerant. So out of those four refrigerant, we have seen the halocarbon refrigerant. Now second type is nothing but azeotropy refrigerant. So have you understood hydrocarbon refrigerant? Yes or no? Are you having any problem related to hydrocarbon refrigerant? Shall we proceed further? Okay. So we'll proceed further. So second type of primary refrigerant is called as a azeotropy refrigerant. So here azeotropy refrigerant means it is a stable mixture of two or more than two refrigerant. That means here that azeotropy refrigerants is nothing but it is a blending of number of refrigerant. It is a mixture or blending of two or more than two refrigerant. But while selecting two or more than two refrigerant, we have to select the pair, or we have to select those number of refrigerant based on category that after mixing those mixture, or that mixture should become as a stable mixture, and whatever refrigerant we are adding, those refrigerant should have identical paper and liquid phase. Identical paper and liquid phase over a wide range of temperature. So here azeotropy refrigerant means it is a stable mixture of two or several refrigerant, two or more than two refrigerant whose paper and liquid phase. Here this is important. It is a stable mixture of two or more than two refrigerant whose paper and liquid phase remains identical over a wide range of temperature. find that paper and liquid phase will remains identical over a long range of temperature if those two or more than two refrigerant which we are going to mix, if those refrigerant will have the same boiling point temperature, same freezing point temperature or melting point temperature, then and then only that liquid phase and paper phase will remain identical for a longer temperature range. That means whatever refrigerant we are mixing in case of azeotropy refrigerant, so we have to take care that those refrigerants should have the near about same boiling point temperature, near about same melting point temperature. And one more care we have to take, that is nothing but after mixing those number of refrigerant, whatever mixture will be formed, that mixture should be stable mixture. That mixture should be stable mixture. Stable mixture means there should not be any chemical reaction between the refrigerant which we are mixing, and it will not form any another byproduct. That will be called as a stable mixture. So here this type of refrigerant will have the mixture of different refrigerant which cannot be separated under pressure and temperature and have fixed thermodynamic properties. That means after application of pressure and temperature, because we are knowing that depending upon pressure, each and every liquid will have its boiling point temperature. That means as pressure decreases or as pressure varies, the boiling point temperature as well as freezing point temperature will goes on changing. So here while mixing two or more than two refrigerant, while selecting the refrigerant which we are going to mix to form azeotropy refrigerant, we have to select those refrigerant in such a way that after application of pressure, also those refrigerants should not get separated. So that is the main concept. So whatever those azeotropy refrigerants are there, those azeotropy refrigerants will be designated azeotropy refrigerant. How to identify whether this is azeotropy refrigerant or not the azeotropic refrigerant? So if that refrigerant number will start from 500 series, if that refrigerant number will start from 500 series, then you have to consider that that is the refrigerant which is following under the category of azeotropy refrigerant. So azeotropy refrigerant, all the azeotropy refrigerants will be designated by 500 series. So for examples of azeotropy refrigerants are nothing but R500, R502, R503, R504. So those are the few refrigerant, or those are the few azeotropy refrigerant. So as all the refrigerant are started with the 500 series, 500, 502, 503, 504. So those will be called as the azeotropy refrigerant. But out of that, whatever R500 refrigerant is there, that R500 refrigerant is nothing but the mixture of R12. That R500 refrigerant will be formed after mixing the R12 and R152. So after mixing these two refrigerant, R12 and R152, so while mixing these two refrigerant, we have to take 73.8% of R12, 73.8% R12, and remaining, that is nothing but 26.2% R152. Then and then only you will form or you will get the R500 refrigerant. Whatever R502 refrigerant is there, R502 refrigerant, that is nothing but the mixing of or blending of R22 and R115, R22 and R115. So here if you see that R12, 22, 23, 32, those are the halocarbon refrigerant, as well as here 152, 115, 113, 13, 115. These are also halocarbon refrigerant. So in case of azeotropy refrigerant, we are mixing two or more than two type of refrigerant, and that may be that may be halocarbon, inorganic, or hydrocarbon. So 502 is indicating the mixture of R22 and R115. Then, but here if you see the percentage, so 48.8% R22 and 51.2% R115. That is nothing but the indication of R502. Then R503, R503 is nothing but 40.1% R23 and 59.9% R13, and R504 is indicating 48.2% of R32 and 51.8% of R115. So this is the azeotropy refrigerant. So next part, that azeotropy refrigerant will have two types. First one will be called as a, wait for 1 minute. So whenever we are mixing or whenever we are forming the blending of two or more than two refrigerant, or whenever we are mixing two or more than two refrigerant to form a single compound, at that time there may be the chances that that refrigerant may be azeotropic or that mixture may be geotropic. So what is the meaning of azeotropic? So after mixing two or more than two refrigerant, if there will be the formation of stable compound, if there will be the formation of stable mixture, and there is only identical phase in case of vapor as well as liquid of those mixture or mixed refrigerant, then that will be called as a azeotropic. And there may be the another case that whenever you are mixing two or more than two refrigerant, so that mixture may not be stable mixture, and that mixture may not get mixed homogeneous mixture. That means that liquid phase as well as vapor phase may not be identical of that refrigerant, so that will be called as a geotropic refrigerant. So geotropic refrigerant or geotropic mixture is nothing but mixing of two or more than two refrigerant, but here liquid phase will different to that of vapor phase. That means there should not be or there will not be the formation of homogeneous mixture, then that will be called as a geotropic refrigerant. So here you will identify that geotropic refrigerant will not boil at this constant temperature like azeotropy refrigerant, because in case of azeotropy refrigerant, whatever number of refrigerants are there which we are mixing, those refrigerants are having the same boiling point temperature, same freezing point temperature. That's why whatever mixture is formed by mixing those refrigerant, that mixture will also have the same boiling point temperature. But here in case of geotropic refrigerant, so those refrigerant will not boil at the same temperature or at the constant temperature, and their liquid and vapor phase will be different, that will not be identical. Liquid phase will differ that of vapor phase, then such type of refrigerant will be called as a geotropy refrigerant. So how to identify that geotropy refrigerant? So that geotropy refrigerant will be designated geotropy refrigerant, that is non-azeotropy refrigerant. Geotropy refrigerant is also called as a non-azeotropy refrigerant. Those will be designated with the help of 400 series. Geotropy refrigerant will be designated but with the help of 400 series. That means if any refrigerant or for any refrigerant, if refrigerant number will start from 400, that may be 401, 402 or anything which will be preceded by 400. So that will be the series called as a geotropic refrigerant. So that geotropy refrigerant will have the commonly used refrigerant called as a R404, R407, R410A, then R413A. If you see here, all the refrigerants are started with the 400 series. All the refrigerants are started with the 400 series. That's why called as a geotropy refrigerant. So if you take the example of R404A, that R404A is nothing but the mixture of R125, then R143A and R134A, and percentage of mixing is nothing but whatever R125 is there, that should be 44%, R143A is there, that should be 52%, and R134A is there, that should be 4%. So after mixing those refrigerant in this percentage, then there will be the formation of R404A. Similarly, R407 is indicating the 23% of R32, then 25% of R125, and 52% of R134A. Whereas R410A, R410A is indicating the 50% of R32 and remaining 50% is nothing but R125A. Then R413, R413A is indicating 3%, 3% of R600A, 9% of R218, and remaining 88% is nothing but R134A. So those will be called as a geotropy refrigerant. Those will be called as a geotropy refrigerant. So whatever azeotropy refrigerants are there, so out of those azeotropy refrigerant, most commonly used azeotropy refrigerants are nothing but R500 and R502. So most commonly used refrigerant are nothing but R500 and R502. Out of that, R500 is nothing but 73.8% of R12, 73.8% of R12, and remaining 26.2% of R152. So here, common properties of R500 is nothing but these are the refrigerants which are non-flammable, non-toxic, and non-corrosive. Non-flammable, non-toxic, and non-corrosive. Then whatever this R500 refrigerant is there, that R500 refrigerant is nothing but the replacement for R12 refrigerant. So if you are going to replace that R12 refrigerant by R500 refrigerant, then you will observe that because of using R500, because of using R500 for against R12, the refrigerating capacity of that system, refrigerating capacity of that system will be 20% greater than the refrigerating capacity of R12 for the same size of motor when used for same purpose. So R500 is beneficial as compared to R12 refrigerant. If you see the boiling point temperature of that R500, the boiling point temperature of R500 is nothing but minus 33 degrees centigrade at atmospheric pressure. Boiling point temperature is nothing but minus 33 degrees centigrade at atmospheric pressure, and the application of R500 is nothing but both industrial as well as commercial application. We are using R500 for industrial as well as commercial application. And last point will be the cylinder color code. So how to identify whether this is R500 or not? So if the refrigerant which is stored in the yellow color cylinder, if the color code of that cylinder where refrigerant is stored is yellow, then it will be the indication of R500 refrigerant. R500 refrigerant. Are you getting? Similarly, there are some properties related to R502 refrigerant. So R502 is nothing but it is the mixture of 48.8% of R22, 48.8% of R22 and 51.2%, 51.2% of R115. So here this R502 refrigerant is extensively used in case of food processing industry. In case of food processing industry, that means whenever we require the refrigeration for any of the food process industry, for any of the food process industry, then at that time first choice of refrigerant will be R502. First choice of refrigerant will be R502. So this refrigerant or R502 refrigerant will be also non-flammable, non-toxic, and non-corrosive. What is the meaning of non-flammable? What is the meaning of non-flammable? Can anyone tell me? What is the meaning of non-flammable? Anyone, please. Varad Lad. Varad. Shubham Raut. Akshay Naiku. Whether you are attending the lecture or not. Aniket Pawar, unmute yourself. Thakre.
लवकर पेटनं घेणार आहे.
So the refrigerant
Yes,
which
yes,
will,
sir.
so what is the meaning of flammable? So whenever that refrigerant will get mixed with the air or any another suitable mixture, so there should not be the formation of flame. There should not be the formation of flame or burning of that refrigerant. That should be called as a non-flammable. So R502 is a non-flammable, non-toxic, and non-corrosive in nature. Then second point is nothing but boiling point temperature of R502. So at atmospheric pressure, the boiling point temperature of R502 is nothing but minus 46 degrees centigrade. Minus 46 degrees centigrade. As I have already told you that R502 is extensively used for food processing industry. That means frozen food lockers, then frozen food processing plant, there then store unit of frozen food and ice cream. There we are using R502 refrigerant. And cylinder color code of R502 is nothing but orchid. You might be knowing that there is one flower called as a orchid. There is one flower called as a orchid. So whatever color of that flower will be there, that color of flower will be called as a orchid color. That will be called as a orchid color. So R502 will be stored in a cylinder which will have the color code as a orchid. So this is nothing but the second type of primary refrigerant. Second type of primary refrigerant called as a azeotropy refrigerant. Called as a azeotropy refrigerant. Now third type of refrigerant is nothing but inorganic refrigerant. Third type of refrigerant is nothing but inorganic refrigerant. What is the meaning of inorganic and organic? What is the basic difference between organic and inorganic? What is the basic difference? Can anyone tell me? Will tell me what is the basic difference between organic and inorganic? Okay, you have to find this. So before, so in case of inorganic refrigerant, so before introduction of halocarbon refrigerant, so whatever number of halocarbon refrigerants are there, organic contain carbon and inorganic, that is the correct answer. So synthetic and natural. So okay, so inorganic refrigerant is nothing but which are available in the nature, and organic refrigerant is nothing but which are produced synthetically. That means whatever halocarbon refrigerants are there, those are coming under the family of organic refrigerant. Those are coming under the family of organic refrigerant, and inorganic means those are naturally available. Such type of refrigerant will be called as a inorganic refrigerant. Okay. So whatever inorganic refrigerants are there, so before introduction of organic refrigerant, or before introduction of halocarbon or organic refrigerant, this inorganic refrigerant were extensively used. Because of their inherent thermodynamic and physical properties. Because here whatever inorganic refrigerants are there, those are possessing inherent thermodynamic as well as physical properties. Only disadvantage of these inorganic refrigerants are those are highly flammable. As well as those refrigerants are toxic in nature. That's why nowadays we are using this inorganic refrigerant under control situation. So whatever these inorganic refrigerants are there, those are universally used for all purposes before introduction of halocarbon refrigerant, and these refrigerants are still in use but under control condition. These refrigerants are still in use because of their inherent thermodynamic and physical properties. Now, which are the refrigerant? Which are the refrigerant which are coming under the family of inorganic refrigerant? Any idea? Which are the refrigerant which are coming under the inorganic category? Whether you are having any idea? So you might have seen that in case of reverse Carnot cycle as well as Bell-Coleman cycle, in case of reverse Carnot cycle as well as Bell-Coleman cycle, we have used the air as a refrigerant. We have used air as a refrigerant. So whatever this air is there, that air is abundantly available in the nature. So that air as a refrigerant will come under the category of inorganic refrigerant. Another example, you can use water. You can use water as a refrigerant. Where you can use the water as a refrigerant? In case of air conditioning plant. In case of air conditioning plant, where you require to maintain the temperature above 0 degree centigrade. Where you require to maintain the temperature above 0 degree centigrade. At that time, you can use the chilled water. You can use the chilled water. That means suppose you are having the water which is having the temperature as a 10 degree centigrade, which is having the temperature as a 10 degree centigrade. So by using the water which is having the temperature as a 10 degree centigrade, you can produce the air or you can cool the air up to 18 degree centigrade, 20 degree centigrade. That means that chilled water can also be used as a refrigerant. Then another example, ammonia. That ammonia is also available in the nature. Ammonia is also available in the nature. So that ammonia is extensively used. This is the oldest and most widely used refrigerant of all the type of refrigerant, because that ammonia is having the highest latent heat of vaporization. Highest latent heat of vaporization. That's why most of the time we are using ammonia as a refrigerant. So that ammonia is also falling under the category of inorganic refrigerant. Then carbon dioxide. That carbon dioxide is also naturally available. So that carbon dioxide is also used. So you might be knowing whatever veterinary doctors are there. Whatever veterinary doctors are there. So whatever bicycle or whatever motorcycle of that veterinary doctors are there. So at the back side, they are always carrying the one cylinder, and in that cylinder they are always storing the injection, different type of injection, veterinary injection. So whenever they will open that cap of that cylinder, you will find that there is a formation of gas or vapors are coming out of that cylinder. So those are nothing but there where those injection are stored in the carbon dioxide, solid carbon dioxide. So that carbon dioxide can also be used as a refrigerant. Then sulfur dioxide, SO2. So for food preservation, we are using that sulfur dioxide as a ripener. So that is also available that is also available in the nature. So those are some of the inorganic refrigerant. So inorganic refrigerants are nothing but ammonia, water, air, then carbon dioxide and sulfur dioxide. Those are the refrigerants which are available in the nature, and those will fall under the category of inorganic refrigerant. So chemical formula of ammonia or chemical formula is nothing but NH3. Water will have the chemical formula as H2O. Air will not have specific chemical formula. Carbon dioxide will have the chemical formula as CO2. Sulfur dioxide will have the chemical formula as SO2. So whatever ammonia is there, ammonia is extensively used. Ammonia is extensively used in case of ice manufacturing industry, as well as cold storages, as well as whatever vapor absorption absorption refrigeration systems are there. Vapor absorption refrigeration systems are there. There also we are using ammonia extensively. Then whatever water is there, that water can be used as a refrigerant in case of steam refrigeration system. In case of steam refrigeration system. So when we are going to deal with the practical, so you are knowing that first 4 practicals are related to the assignment. So there you will come under the concept of steam refrigeration system, where we are using water as a refrigerant. Then whatever air as a refrigerant is there, that air as a refrigerant we are using in case of air refrigeration system for aircraft refrigeration. That means in aeroplane refrigeration system we are using air as a refrigerant. Carbon dioxide. So in case of ship refrigeration, that means while transportation of any perishable food or any perishable product from one country to another country via sea, there we are using carbon dioxide as a refrigerant. And sulfur dioxide. Next refrigerant is nothing but sulfur dioxide. So we are using the sulfur dioxide as a ripener. जर केळी वगैरे जर पिकत नसेल तर आपण काय लावतो त्याला, किंवा एखादं फूड आयटम असेल ते जर पिकत नसेल तर त्यावेळेस आपण काय लावतो, सल्फर डायऑक्साइड लावतो. ॲज अ रायपनर वी आर युझिंग सल्फर डायऑक्साइड as well as in for food preservation also we are using sulfur dioxide. So if you see the refrigerant number of those inorganic refrigerant, so that ammonia will have the refrigerant number as a R717. Ammonia will have the refrigerant number as a R717. Water will be represented by the R118, or that can also be represented as a R718. Water will have the refrigerant number as a 118, R118 or R718. Then whatever air will be there, that air will have the refrigerant number as a R729. Then carbon dioxide, that carbon dioxide will have the refrigerant number as a R744, 744. And whatever sulfur dioxide will be there, that sulfur dioxide will have the refrigerant number. Sulfur dioxide will have the refrigerant number as a R764. Now, how that inorganic refrigerants will be designated? So there is also one designation system for inorganic refrigerant. So that designation system is nothing but R700 plus molecular weight of that refrigerant. R700 plus molecular weight. R700 plus molecular weight. Now here whatever ammonia is there, ammonia chemical formula is nothing but NH3. What is the molecular weight for nitrogen? Can anyone tell me? What is the molecular weight for nitrogen? Nitrogen will have the molecular weight as a 14. And what is the molecular weight for hydrogen? Hydrogen will have the molecular weight as a 1, but as N3, H3 is there, so 3 hydrogen atoms are there, so molecular weight of H3 will be equal to 3 into 1. 3 into 1. So 14 plus 3 into 1, that will become as a 17. So R700 plus 17, that is nothing but R717. R717, that is nothing but the refrigerant number for ammonia. Similarly for water, H2O. What is the molecular weight for hydrogen? 1. But as 2 hydrogen atoms are there, so 2 into 1. What about oxygen? So molecular weight of oxygen is nothing but 16. So 2 into 1 plus 16, that is nothing but 18. Total is nothing but 18. So R700 plus 18, that is nothing but 718. R718, that will be called as a water. Here there is only exception for water. So water can also be designated by R118 also. R118 or 718. Both the way you can designate for the water. If you are considering the example of air, if you are going to consider the example of air, what is the molecular weight of air? That is nothing but 28.95 something. 28.95 something. So that is the molecular weight of air. So 700 plus this will be round up, that is nothing but 29. So 700 plus 29, that is nothing but R729. That will be the refrigerant number for air. Then what about carbon dioxide? CO2. What about the molecular weight of carbon? Can anyone tell me? What about the molecular weight of carbon? You can write in the chat box. 12, correct. 12. And what about 12 plus oxygen will have the molecular weight as a 16. So as 2 oxygen molecules are there, that's why 2 into 16. 2 into 16. So that is nothing but 16 into 2, 32 plus 12. That is nothing but 44. That is nothing but 44. So 700 plus 44. So carbon dioxide will have the refrigerant number as a R744. Carbon dioxide will have the molecular refrigerant number as a R744. And last one is nothing but sulfur dioxide, SO2. What about the sulfur? What is the molecular weight of sulfur? Sulfur will have the molecular weight as a not 33. It will have the molecular weight as a 32. 32 plus oxygen will have the 16 as a molecular weight. 2 oxygen molecules are there. That's why 2 into 16. So 16 into 2 is nothing but again 32 plus 32. That is nothing but 64 plus 700. That is nothing but R764. R764. So in this fashion, that inorganic refrigerants will have the will be nomenclated. Are you getting? Yes or no? Nomenclature of inorganic refrigerant. So next point is nothing but nomenclature of inorganic refrigerant, which I have told you. So this will be designated by the number 7 followed by the molecular weight. That is nothing but R700 plus molecular weight. So few example, ammonia will have the molecular weight as a 17. That's why designation will be R717. Water will have the molecular weight as a 18. That will be designated as a R718, or sometimes it can be written as a R118 for multiple choice question. This designation system will be asked. That means R764 will indicate the refrigerant, or give the name of refrigerant for R764. Or for general knowledge purpose also, you should remember this designation system. Sulfur dioxide will have the molecular weight as a 64, hence designated R764. Carbon dioxide will have the molecular weight as a 44, hence that will be designated as a R744. Now, out of those inorganic refrigerant, ammonia will be extensively used refrigerant. Ammonia will be extensively used refrigerant. So we will see some of the properties related to ammonia. So whatever ammonia as a refrigerant is there, that is one of the oldest. Ammonia is nothing but one of the oldest and most widely used refrigerant of all the category of refrigerant. So whatever ammonia refrigerant is there, that ammonia refrigerant is having the boiling point temperature. That ammonia refrigerant is having the boiling point temperature as a minus 33.3 degrees centigrade. Minus 33.3 degrees centigrade, and melting point temperature minus 33.3 कशाचा आहे बॉइलिंग पॉइंट म्हणजे minus 33.3 डिग्रीला काय होणार आहे लिक्विड अमोनियाचं कन्वर्जन पेपर अमोनियामध्ये होणार आहे आणि minus 78 डिग्री सेंटीग्रेडला काय होणार आहे सॉलिड अमोनियाचं कन्वर्जन लिक्विड अमोनियामध्ये होणार आहे ऍट ऍटमॉस्फेरिक प्रेशर. So whatever ammonia is there, that is most commonly used for cold storages, then that will be used in case of ice manufacturing industry, as well as that will be used in case of paper absorption refrigeration system. It will be also used in case of vapor absorption refrigeration system. So boiling point temperature minus 33 degrees centigrade. Melting point is nothing but minus 78 degrees centigrade at atmospheric pressure. So as I have already told you, ammonia will have the highest latent heat of vaporization. Highest latent heat of vaporization. So as in the evaporator, normally we are operating evaporator in the temperature range of minus 10 to minus 30 degrees centigrade. So whatever ammonia is there, that ammonia will have the latent heat of vaporization at minus 15 degrees centigrade. That is nothing but 1315 kilojoule per kg. That means if you are having 1 kg of liquid ammonia, if you are having 1 kg of liquid ammonia, and if you want to convert that 1 kg of liquid ammonia into vapor ammonia, then that ammonia needs to absorb 1315 kilojoule per kg of the heat, 1315 kilojoule per kg of the heat from the substance which you want to cool. Whereas comparative to this, whatever rest of the all the refrigerants are there, those will have the lowest latent heat of vaporization. If you are going to compare, or if you are going to consider R11, so that R11 refrigerant will have the latent heat of vaporization as a 195 kilojoule per kg at minus 15 degrees centigrade. 195 kilojoule per kg, whereas ammonia is having 1315 kilojoule per kg. So whatever ammonia is there, that ammonia is a colorless, it is poisonous. That ammonia is a poisonous. That's why wherever we want to use the ammonia, that ammonia will be used very or that should be used carefully, because it is a poisonous to human being. So if that ammonia will come in contact with the human body because of leakage, then there will be the problem of irritating to eye, nose and throat. And it is also highly flammable. It is also highly flammable when that ammonia will get mixed with the air. It is flammable when it will get mixed with the air. But the most important property of that ammonia, why we are using still ammonia in most of the application, that is nothing but that ammonia is having the very good thermodynamic properties. Very good thermodynamic properties. So it is neutral to all the metals, highly soluble in oil, and it is volatile as well as non-toxic, but in higher concentration. Sorry, it will be toxic, not non-toxic. It is a toxic, and that should be in higher concentration. Volatile as well as toxic in higher concentration. So those are the some basic properties related to the ammonia. Some basic properties related to the ammonia. Second refrigerant is nothing but under the category of inorganic refrigerant. Second refrigerant is nothing but sulfur dioxide. Second refrigerant is nothing but sulfur dioxide. So this sulfur dioxide refrigerant is used as a household refrigerator before introduction of halocarbon refrigerant. But nowadays we are not using that sulfur dioxide as a household refrigerator. This sulfur dioxide is also toxic. This is 1 minute. This is also toxic. This is non-explosive and non-flammable as well as non-corrosive. As well as non-corrosive. It is irritant to human body when it will come in contact with the human body. It is non-mixable with the oil. Here, if you see the latent heat of vaporization for ammonia, the latent heat of vaporization for ammonia is 396 kilojoule per kg, which is very low as compared to this is the latent heat of vaporization for sulfur dioxide, not ammonia. It is latent heat of vaporization for sulfur dioxide, that is nothing but near about 400 kilojoule per kg, whereas ammonia is having the latent heat of vaporization as a 1315, which is almost 3 to 4 times greater than sulfur dioxide. So it is low latent heat of vaporization. Boiling point temperature. Boiling point temperature of ammonia, sorry, not ammonia, sulfur dioxide. Boiling point temperature of sulfur dioxide is nothing but minus 10 degrees centigrade. and it is commercially used as a ripener as well as preservative of food. Ripener as well as preservative of food. So those are the some of the common properties related to the sulfur dioxide. Related to the sulfur dioxide. Now last type of primary refrigerant is nothing but the hydrocarbon refrigerant. Last type of primary refrigerant is nothing but the hydrocarbon refrigerant. That hydrocarbon refrigerant will fall under the category of organic refrigerant. So as the name itself indicating hydrocarbon. What is the meaning of hydrocarbon? What is the meaning of hydrocarbon? That means this refrigerant will be the combination of carbon as well as hydrogen. This refrigerant will be the combination of carbon as well as hydrogen, such like methane, ethane, propane, butane. So what is the chemical formula for methane? CH4. Ethane, C2H6. Propane, C3H8. Butane, C4H10. So those will be called as a hydrocarbon refrigerant. So that hydrocarbon refrigerant will fall under the category of organic refrigerant or organic compound. So many hydrocarbon refrigerants are successfully used as a refrigerant in case of industrial as well as commercial installation. In case of industrial as well as commercial installation, we are using that hydrocarbon refrigerant. But main disadvantage of this refrigerant, and because of which we are not using extensively those hydrocarbon refrigerant, that is nothing but those hydrocarbon refrigerant, as these hydrocarbon refrigerants are containing the carbon and hydrogen. That's why those refrigerants are highly flammable. These hydrocarbon refrigerants are highly flammable. So though those hydrocarbon refrigerants are consisting satisfactory thermodynamic properties, then also there are some limitations to use that hydrocarbon refrigerant in many of the application, because those are highly flammable refrigerant. So under that hydrocarbon refrigerant, the refrigerants are nothing but methane, which is having the chemical formula as a CH4, ethane, which will have the chemical formula as a C3 or C2H6 or CH3CH3, propane, that will have the chemical formula as a C3H8. Then you can take the next refrigerant as a butane. Which will have the chemical formula as a C4H10. Or you can have the next refrigerant as a isobutane also. Isobutane means same chemical formula, C4H10. Only whatever hydrogen position will be there, that position of hydrogen will goes on changing. So here, if you see the refrigerant number, the designation system for hydrocarbon refrigerant will be similar to that halocarbon refrigerant. That is nothing but RXYZ. Whereas Z was indicating the number of fluorine atom. So if you consider methane, CH4, whether fluorine atom is present? No. That's why value of Z will be equal to 0. Y will be indicating number of hydrogen plus 1. How many hydrogen atoms are present? Here number of hydrogen are nothing but 4. So 4 plus 1. Hydrogen plus 1. So 4 plus 1 is nothing but 5. And third digit is indicating number of carbon minus 1. How many carbon atoms are present? 1 carbon atom is present. So carbon minus 1 is nothing but 0. So 050. That is nothing but the refrigerant number for methane. Similarly for ethane, C2H6. So here Z, value of Z, fluorine atom is not present. That's why value of Z will be equal to 0. value of Y is indicating hydrogen plus 1. 6 hydrogens are there. So 6 plus 1 is nothing but 7. And third digit is indicating carbon minus 1. Number of carbon atoms are nothing but 2. So 2 minus 1 is nothing but 1. So R170. R170 is nothing but refrigerant number for ethane. Similarly, you can find out the refrigerant number for propane. That will be 290. If you are going to consider the butane, so that refrigerant number or designation system for butane will be different. So whatever this same system will be there, that will not be applicable because number of hydrogen will be 10 in case of butane. Number of hydrogen will be 10 in case of butane. So 10 plus 1 will be equal to 11. So there that law or this designation system will get violated. So butane will have the refrigerant number as a 600, or that will have the isobutane will have the refrigerant number as a 600A. So this is related to the hydrocarbon refrigerant. So in today's lecture, we have completed all the type of primary refrigerant. We have completed all the type of primary refrigerant. So today we are going to stop here. In the next lecture, we are going to see what is meant by secondary refrigerant, what are the different type of secondary refrigerant, then what are the different properties of refrigerant, and last point will be what is the effect of refrigerant on the environment. So these 3 points are remaining from this chapter, entire chapter. So it is possible to cover this entire chapter within one lecture also. So in the next lecture, we are going to complete or we are going to finish this chapter. So thank you for attending this lecture. Now you can write down your roll number. And after writing the roll number, you can exit the lecture. It is being observed that many of the students are joining the lecture in the last 5 to 10 minutes for attendance purpose. So I am getting the record of the student when those students are joining on my system. So don't join only for attendance purpose. You can write down the seat number and you can exit the lecture.